Okay, welcome to ATAR math exam preparation. Today we are going to discuss the QCAA External Assessment 2020 Paper 2, question 17. This is a complex familiar question. You can see the topic is differential equations. It's Unit 4. All right, so the question says object released from the rest at a height of 100 meters above the ground. So let's say if this is the ground, so we say it's 100 meters above ground. So if I say this is the height, so that's the particle, 100 meters. So if I say this is the origin, so that means we to particle drop. So we want so what is question say when obviously at the rest, so beginning as a v when v equal to 0, the displacement, which is on the reverse side of the origin, so there'll be x equal to negative 100 meters. So this is the important condition to know. So then we need to also give you velocity with the displacement using this particular differential equation. So 0.004, I'm going to write into fractions. So it'll be 250, 1 over 250 v squared. So v is greater than or equal to 0. So those conditions are given. So we need to find out. So what is the velocity? So we need to determine the velocity when the displacement. So we find a velocity function first. Then we need to decide when the object hit ground, what is velocity means when x equal to 0. So what is the velocity when the displacement is 0? Back to orange. So now we're going to start doing the Vx first. So how do we so this is the key things first. So how do we find a velocity function in relation to displacement? So obviously we're going to solve this. So we're going to, let's do the step 1. We're going to isolate velocity to the left-hand side and the x to the right. So what I'll do, I'm going to move v divided by 9.8 minus 1 over 250 v squared dv equal to dx. So basically I move this thing to the left, then with a v. So can you see this step 1 we call isolated variables, v on the left, the x on the right. So now we're going to do the integrations on both sides. So on the left-hand side, we're going to, so we're going to say if I'm going to move, so we're going to differentiate first. On the left-hand side, we're going to put a d because this is the denominator. Now this is a square. So instead, so we're going to put d 9.8 minus 150 times by v squared. So I'm going to move into the integrated into the d. But if you integrate d, you must put a half in front. And also you need to times by the negative of that. So we need to times by. So therefore, we need to put step. So half first, then multiply by the negative of the reciprocal of that, which is 250. So that's the front. Then the denominator we still copy. So I'm going to put a D a little bit, right a little bit better. So I put a D 9.8, 1 over 250, V squared. Now, can you see these two are exactly the same? And because I did a coefficient, so that's why we put on the left-hand side, but the right-hand side, I'll just copy dx. So now I'm going to integrate. So this is obviously this is going to be negative 125. All right, I'm going to integrate at both sides. So I'm going to say d 9.8, 1 over 250 v squared divided by 9.8, 1 250 v squared. So that's two same. Equal to right hand side, I'm going to do dx, integrated dx. So you antiderivative. Now we said, so that's the left-hand side is 100, negative 125. Now this is obviously is a log. You can see this is the composite function. So integrated to log absolute value 9.8 minus 1 over 250 v squared. Equal to right-hand side is x plus c. So this is my equation. Now, this is not quite the Vx, but it's a relationship between V and X. But we need to decide what is the C so that we can get a definite answer. This is the answer is not definite. So that's why we're going to use the next condition we just given. So we know when the initial velocity is 0, when x equal to negative 100. So that's the given condition we just talked about. So we substitute into the formula, we put a negative. So if we're going to put velocity equal to 0, so that guy is 0 now, this has become 0. So therefore the left-hand side becomes 125 log 9.8 equal to negative 100. So x is negative 100 plus c. So now we can find it using graphics calculator, find a c approximately equal to negative 185.9298. So that's a c. So now we have got the equation, the relationship between velocity and so our equation will be 9.8 divided by 1 over 250 v squared equal to x minus 185.298. So that's my relationship between velocity and x. Now we're going to find a velocity. So what is the velocity when x equal to 0? So what I'll do is I'm going to replace x with the 0, then find what is the v. So Then a substitute. Left-hand side, 9.8. So we don't know what a V is. Equal to negative 185.298. So now we have to use GC, graphics calculator, to find the velocity. Using GC, pretty easy to find it. So velocity approximately. So when x is to 0, approximately equal to negative 36.7. So what's negative? Because the point on the opposite direction. All right, so we got two, actually we have two answers because of positive and negative. So this is a positive and negative. So you got two answers. However, velocity must be positive. In this case, must be positive or equal to 0. That's condition because of that. So therefore, we choose the positive answer. So that's approximately. So that's why when the hit to ground, the answer has to be 36.7 meters per second. So that's my answer. Now this question is integration using the differential equations. The key is using the logarithm, which is a natural log, to find the left-hand side. So this is my solution. So if you like the video today, please give us thumbs up and don't forget subscribe the channel so you can get more videos later. Thank you for watching and I'll see you next time.